My name is Ben Humphreys, and I'm a physician scientist and nephrologist, and I care for patients with kidney disease. I also co-direct the Harvard Stem Cell Institute Kidney Group with Andy McMahon. There are over 400,000 patients that suffer from end-stage renal disease, which means they require hemodialysis or peritoneal dialysis. And this is a life-saving procedure, and it was really invented over 50 years ago. But it is a procedure that requires patients to travel to a dialysis center 3 times per week for 4 hours per session. They're often very tired after dialysis, and it really impairs their quality of life, although it does keep them alive. Unfortunately, we do not have great therapies to offer the millions of patients who are in late stages of kidney disease who are not yet on dialysis but are progressing toward dialysis. With the tremendous increase in the incidence of diabetes in the United States, we anticipate that in the next 20 years there will be millions of patients on dialysis. So this represents a tremendous burden to the healthcare system and to patients suffering with kidney disease. The kidney is a remarkable organ in that after an acute insult, an acute injury, even one that might require us to put a patient on dialysis, with time, often patients will come off dialysis because their kidneys have undergone a healing process. We really seek to understand that endogenous kidney repair so that we can design drugs or therapies that help to push that repair process along or to block aspects that are maladaptive. The challenge is if we don't understand which cells are responsible for repairing, it's very difficult to target them. And so one of the things that we've been able to do collaboratively through the Kidney Group is to use a specific technique called fate mapping to really nail down with certainty those cells that are responsible for repairing the kidney. Another important accomplishment over the last several years has been the definitive identification of kidney stem cell population during development. And this work, which was performed in Andy McMahon's lab along with Akio Kobayashi and Todd Valerius, provided the first definitive evidence through genetic fate mapping that in the metanephric mesenchyme there are stem cells able to differentiate into all the different epithelial lineages found in the adult kidney. One of the really fascinating things about kidney development is if you put kidney progenitor cells during development in a petri dish with the right factors, they really want to differentiate and turn into kidney tubules. And so to a certain degree, it's a matter of isolating the cells at the right time and giving them the right environment and the right factors, and they will differentiate on their own into kidney tubules and collecting ducts and many of the complex architecture of the kidney. And so this advance really allows us to have a set of tools which we hope will enable this kind of tissue engineering in the future.